In this episode, Matt Brown from the infamous YouTube channel at Matt Brown with no O joins us to talk about firmware, reverse engineering, and supply chains. Welcome, everyone, to episode 37 of the Eclipsium Below the Surface podcast. I'm your host, Paul Asadorian. I'm joined by Mr. Alan Alford. Alan, welcome.
Thank you.
It's good to have you, man. It's good to see you. It's been a while.
It
Took
has
a
been a
little
while.
hiatus, but we're back. This is episode 37 for September 4th, 2024. Want to remind everyone to make sure you visit eclipsium.com/go. There you'll find the ultimate guide to supply chain security, some on-demand webinars I delivered on the topic of digital supply chain threats and risk, as well as a customer case study. And of course, you can sign up for a demo, all that at eclipsium.com/go. I am very excited for our guest for this episode, Mr. Matt Brown. I was like starstruck when Matt and I met. I've been following your YouTube channel, Matt, for some time now, and it is topics very relevant to my interests. And you're doing an amazing job and just cranking out the content, man. I checked today, and you had like 6 new videos. So, Matt, welcome to Below the Surface.
Well, thanks for having me. Yeah, and it's exciting. It's an exciting field to be in, and excited to have a conversation.
Absolutely. So, Matt, how did you get your start in information security?
Oh gosh, so it probably hails back to I just like to tinker. I like to tinker with technology, computers, and stuff like that growing up. And I remember I was at a bookstore one day, and I picked up this book on like using Wireshark and just like sniffing packet data over the wire. And for some reason, that just really intrigued me. This is also the day where like everything was clear text HTTP, so it was a little more interesting. Although you still find some of that today. And so I just started exploring, like seeing, like learning about these networking protocols by just like scrolling through Wireshark traffic. Eventually went to college and fumbled around from computer science to MIS and just kind of like interested in technology and learning new things all the way. And then in my career, I kind of got introduced to hardware security through some side projects as well as some stuff at work, and just love buying random devices out there and ripping them apart and seeing how they work on the inside, which is kind of hails back to how I got into it in the first place, just interested in learning.
It's amazing. Like you're pretty much all self-taught then, right?
Yeah, exactly. Like I definitely have the more formal education route, but I would say through that experience, it was all of the stuff I was learning on the side that really gave me the core skills, the core technical skills that I have today, and that I show off on the YouTube channel. Yeah, definitely.
That's awesome. So what led you to create the YouTube channel?
Oh gosh, so that's a whole story. So I watched Louis Rossmann for a long time and his MacBook repair videos, and he would put up these like really long form, unedited videos, and he got tons of views. And I was like, whoa, there's an audience out there that has not. There is a remnant of people on the internet that will listen to long form content and are not so have such a short attention span, right, that they'll just like click off in like a couple minutes, right? And so I'm really passionate about hardware and seeing everything Louis did under the microscope. It was all really interesting, and I was like, okay, I kind of do some of those same things, but in the security world, in the hardware security world. And so I just thought I would start cranking out some videos. And I'm not good at video editing, so very minimal edits and just kind of showing the real world of trying to solve a problem. You run into roadblocks, you overcome those roadblocks. And so showing that all, I think the audience has appreciated that. And it's refreshing to see that there are still people who will just, it's kind of like the old YouTube that people talk about sometimes. It's like back in the day when there wasn't all this editing and clickbait and stuff like that. So there can still be a remnant of that exists on the internet, which is cool. So
That is
Yeah.
too cool, man.
Yeah, we appreciate it, man, because it's great content. Even if you're not analyzing those specific devices, I flag a lot of that content for like stuff I might need to refer back to. I might be doing something similar, and you've got like the example on how you did maybe on a different platform, but I'm like, oh, I want that technique, right? That process is one thing I want to try, right? And I think that's why it's super important to maintain this content.
yeah, no, and I'm just happy to contribute to it. Like I mentioned, yeah, my inspiration, Louis Rossmann, um, he put all that content out there, and it's like I was able to learn things. I work in a completely different context. I'm never gonna repair a MacBook motherboard, but
Right. Yeah.
but I still learned things about the equipment, the techniques, and I can apply that to something else that's cool as well. So yeah.
So what were the first things that did you start with, like hardware, like, soldering onto the board, getting serial, or did it start more on the software side and then the hardware kind of progressed?
Yeah, I mean, I've always kind of been in that like embedded Linux pen testing space. That's the work part of this interest. That's where that really was driven from. And so, yeah, the hardware access for me, and this is also true now in the bug bounty work that I do. It's usually a means to an end. I'm not like, I'm not doing the hardware security work where it's like so low level and I'm just attacking like the silicon. I'm usually looking to extract the software out of the system and then like attack the software system, uh, gain access to UART console, which lets me debug my attacks now in a more white box way than having it be completely black box over the network.
Yeah, the IoT landscape is very interesting today. And Matt, I want to get your take on like what are your thoughts on the supply chain, where all these components come from, and some of the vulnerabilities and weaknesses that they might have in common. I'm sure you've seen similar, hardware and firmware across all of these systems, right?
So that's really funny. So I'm preparing to do a video. So recently I've gotten into looking at smart scales. These like IoT scales, and they do more than just weight. They do like body composition and stuff like that. It sends like it's kind of fascinating science. It sends like electricity through your body, and then your body's like body fat versus muscle has different resistance values. There's some of the science stuff that's interesting, but
it can calculate a BMI for someone, right? Body mass index. And
exactly.
Some of the early ones I remember, I think it was Leo Laporte from Twit. He had one that was send his weight out to his Twitter account every day as like a check. Like, I'm putting this out as public, right? So I better start losing weight because everyone's going to see it, right? So it's interesting use cases.
Oh yeah, for sure. Yeah, and what's really interesting about that, so you need some of that. You need other pieces of data about you, some kind of like sensitive PII to do that BMI calculation, which is kind of interesting.
You need height, weight, the whole thing.
Yeah. So I've been reverse engineering one of these scales that I got from China, and I did a video on it. I reverse engineered the Bluetooth protocol and found out that I could unauthenticated, rip all that data out of the scale, like the BMI reading, your gender, height, and weight, because it sent all that and stored it on the scale permanently, so that it could do the calculation, it could do the math on the scale at the edge.
Right.
Now the fascinating thing. So getting back to the supply chain thing. I got a comment from somebody. So like here, I actually got these scales down here. So this is the scale that I looked at, and then somebody was like, "Hey, I have the Wise one. It looks the same." And then I was like, so even before I bought the device, I was like, all right, let me figure this out. So I took apart the mobile APK of Wise versus iHealth. These like two devices. Turns out you find like tons of common code. Like it's not the same code. It's obviously like copy and pasted, right? Which is like, it's hilarious. So like you hear all this stuff in the IoT security space about like SBOM now, right? That's it's a big hot topic.
Yeah.
And it's just hilarious in these more consumer grade IoT devices because there's no way they're tracking that, right? It's like, one guy's like, hey, give me that source code, like ship it over here so I can copy and paste it into this other project, right? And so you have hardware that's really similar, like the hardware's similar and the software's similar. It's kind of like an archaeological dig where you're like tracking back, some common culture to which multiple different divergent devices are emerging out of. And so it's got like that's a thing that interests me about the IoT world too, is like those supply chains and the business markets and dynamics that create some interesting security problems.
Well,
let's just say
your model presumed, hey, send me the code. That's the friendly interpretation, right?
100%.
I've worked in the IoT space where I don't know, I'm not going to name names, but Huawei produced some really interesting stuff that looked eerily familiar to products I myself worked on.
Right.
It was, so there's a lot of that goes on too, right? And,
it's
it's
also
the old story about the microwave oven that they, the Chinese reconstructed a US made microwave, including some random flaw that was in the original model got reproduced in the Chinese clone. And that's how they knew it was a ripoff was, oh, look, it's got that same stupid hole that shouldn't be there. That kind of thing, right?
Yeah.
I think that SBOM landscape and that the common culture that you allude to, I think oftentimes there's offshoots that are illicitly obtained offshoots, if you will, and defects and all come bundled with, right?
100%. So, and it's fun to explore this space. So, in my lab, I've got, tons of this, gear to be able to extract firmware off of devices, right? Well, all these devices, like the really good firmware extraction devices, I mean, they're all sourced. They're all made at, like, that software is actually like made and written overseas. And you're like, well, why do you think they're so good at ripping firmware out of stuff over there, right?
That's a really interesting point. Well, before we get to your favorite extraction tools, Matt, I want to talk about the supply chain, because you mentioned APK and Android, and it sounds like the scales are very similar to the Android set-top boxes, where the hardware is very similar, and they source the hardware from different places, but it ends up being pretty similar. And then they go, well, we need an operating system to run this. And I think there's only like a few people that make an operating system that they can go to and just like, oh, here's a customized Android operating system that will go on that hardware with some minor customizations. And it's all pretty much cookie cutter the same. When I looked at those set-top boxes, and there was another blog post series, a 6-parter that I can send you, Matt and Alan, that deconstructs all of the the firmware across these set-top boxes and finds many similarities. So I think the supply chains are narrow, and to both of your points, whenever there's a defect or vulnerability, it just gets bundled right in, right? And we don't know because they're not producing an SBOM. So it's an interesting place to be.
Yep. And sometimes they're like, and sometimes they'll like refactor the code. So even some kind of like, static code analysis tools that'll try to find, similarities. Like sometimes you'll get success out of that, but sometimes you won't.
So the challenge is when, and I think it's a good segue, right? Because we don't get an ingredients list, an SBOM, from many of these devices, not just in IoT, but we go to commercial VPNs and firewalls that are getting attacked 6 ways to Sunday right now in the attack landscape, right? We don't get a good list of ingredients, and so we're left to validate the ingredients ourselves. And the first step that you've already identified is we need to extract the firmware. So what are some of your favorite tools, both hardware and software? And you said some of these tools are made in China. I know a big fan of the Bus Pirate. Ian does a great job with that platform, right?
Oh yeah, that's a really solid platform. So my go-to, I mean, it's this Chinese-made device. The software is Super Sketch. I've heard stories about what could be in that software. I don't know.
Right.
I try not to think about it. But the XGeku stuff, I've got it somewhere here. But it's these readers, and then there's separate ones that do eMMC chips. I mean, the XGeku platform is pretty much my go-to platform. You can buy it on eBay pretty cheap. The software is actually, they actually update it every once in a
Nice.
while. So there is some kind of support and community around this device. So
Now, does that the XGecko platform, does that have something you can clip on as well as if you desolder a chip and read it? Is it both or just one or
yes,
the other?
you can do in-circuit programming. I tend to lean away from that. Sometimes you'll have issues where it'll try to power other parts of the circuit
Yeah.
when you're performing that. And I'm just, I don't know. I get this question all the time of like, Matt, in your videos, you're always like pulling the chip off and doing it
Right.
that way. Why do you do that? Why don't you do it in circuit? Why don't you clip onto it? That's a really
Mhm.
common comment that I get. And for me, like again, hailing back to Louis Rossmann, I learned all these like soldering skills and I just practiced them over and over again to the
Mhm.
point where I can reliably pull just about any chip off, except for BGA, but I'm learning that as well. Doing
What is BGA?
BGA as a ball grid array, so
Oh, okay.
it's
Yeah.
where there are 153, 169, little solder balls on the size of a chip that's about the size of a penny, right?
Mhm.
And so you have to have these stencils and solder paste that will like put the solder exactly where you want it, and then you have to place the chip very nicely and throw hot air on it to get it to go back on the board, right?
Right.
Now,
Right.
if
Yeah,
you're
'cause
just interested in the firmware extraction and then you're done, then you
Yeah.
don't then you don't care.
Right. Putting it back is always the issue. It's harder to
Yeah,
put chips back than it is to take them off.
it is, yeah. But again, like kind of being like a student watching Louis Rossmann do all this stuff with hot air, I've gotten good at doing that for any chip other than BGA. And like I said, that's like the next mountain I'm trying to climb is getting really good at that.
So in terms of what you do extract, like BIOS, UEFI, FPGA, like what's kind of the wealth of the things that you have a relative ease in terms of pulling it from the board, ripping the code out. What are you playing with?
Yeah, so I'm focused on like Linux embedded devices most of the time. Sometimes you'll have microcontroller RTOS type devices where they'll have external flash, right?
Yeah.
Because the flash that's embedded in the microcontroller is actually pretty hard to get out if they turn off the debugging. There you have to resort to glitching.
Right.
To be able to disable the read protection and then read that firmware out. But for these Linux-based devices, it's pretty much all there. You can pretty much grab the entire firmware content. So that's going to include usually like some kind of little first stage bootloader, and then like U-boot is going to be a second stage bootloader, your kernel, and then a bunch of file systems that are going to differ based on what type of file systems they're using. But
So-
all like embedded type flash-based file
Embedded
systems.
Android, embedded Linux. Is PSOS still around? Is anybody using any of these other more obscure? There used to be something River had an OS that was proprietary. There was PSOS. There was
yes.
Wind River, right?
Wind River. There we
Yeah.
go.
I interacted with those a long time ago. There used to be RTOSs like that. They used to be relatively common for Wi-Fi routers, but now those are all getting replaced by ARM-based, Linux stuff. But I took a pretty cool course on RTOS hacking, and there were multiple RTOS vendors, and those are very interesting from a reverse engineering and exploit situation. They don't have a lot of the protections, the memory protections that Linux does nowadays. You'll still find some really old Linux stuff running on old kernels that don't have the memory protections that we have today. But for the most part, those RTOSs are a little easier to attack. Yeah.
Okay.
And the RTOSs, do they have a kernel and a file system?
So they can support file systems, but most of the time it's not. So there are on a microcontroller you can build out a kind of operating system like FreeRTOS, things like that. You can do that, But most of the time on your like bare metal microcontroller, it's almost like because I come from the Linux world, so I understand everything through that lens of a more traditional operating system like that.
Mm-hmm.
It's kind of like a statically compiled binary that
Right.
it
It's just
just
code running on the chip.
it's just and it's just one, right? It's like there was only one process. That's what an RTOS. That's how I
Yeah.
view an RTOS. It's
No,
like
it's a
one
great
statically
description.
compiled binary. When the CPU fires on, it launches that program, and then when the program exits, the CPU halts, right? So that's why you have like a loop that just keeps looping forever, and you do all the stuff you want to do. Yeah.
I gotcha. Yeah. I've started to dabble in some of the micro, like consumer or hobbyist microcontroller
Yeah.
type stuff, like Arduinos and stuff like that would all be microcontrollers that operate very similar.
Yeah, and I'm not, again, like I'm more in the Linux space than the microcontroller space, but I'm trying to get into that as well. And like I mentioned, those glitching attacks, because most of the attacks I want to do, I want to get firmware so that I can reverse engineer it, so that I can find vulnerabilities that are exploitable over the network. Right? Like it's a means, all that firmware extraction is a means to the end of finding some vulnerability that is more accessible for the attacker than having physical, possession of a device. Yeah.
Right.
So I'm thinking in terms of SBOM, right? Like,
Yeah.
let's imagine it's Linux and a traditional OS on a server, right? I can go through and I can say, you are running kernel version X. You are running, this distro. You have the following packages installed. You have the following services enabled or the following services disabled. I can get a really clean snapshot of what that Linux posture is, generate an SBOM that'll actually tell me a pretty comprehensive story about, okay, this is what I'm actually looking at with this device. When it's embedded, what's the pivot there? How does that SBOM story play out in the embedded Linux ecosystem?
Oh, it's not pretty, let's just say. So I've because I in my professional experience, I've gotten to kind of see behind the curtain and see what these SDKs, these build systems for these embedded Linux systems look like, and it's usually just a cobbled together mess of stuff. I'm not gonna name drop a company here, but in the embedded space, there's a lot of these very specialized embedded processors, right? They will build a SoC that is ARM based, but then they'll add in their own stuff in silicon, right?
Mm-hmm.
And then they need to build drivers for this, right? And
license a driver from another supplier.
Exactly. And so that is often just like, again, we're talking again about, copying and pasting and throwing code around. Like that happens in the kernel on these embedded devices. There will be a build system that has this custom kernel modification and just a huge list of kernel patches, right? So if you got into the shell on the system and you ran, uname-a and you saw the Linux kernel version, that's not telling you the whole story in terms of your SBOM, right?
Okay.
Because you have all of these custom patches and drivers that are being written for their own custom silicon that's doing, video encoding or AI acceleration, all in the silicon that you just will have no visibility into unless you can go back and see and you have source code access. But even sometimes, like understanding the source code, I've been in situations where we have access to the company that provides these embedded build systems, and they will say, oh yeah, like the person that wrote that code, like you'll see at the top of the file, like it'll say their email, right? They're like, oh yeah, they haven't worked here in a long time. And like even the company that's providing these build systems will not have visibility into the code and how it works, which is really scary.
What you just explained
too, right?
Yeah, exactly. Oh yeah, there's mirrors here and parallels into the corporate world for sure. But Matt, what you just explained was why a lot of these devices, when we lift up the hood, we find Linux kernel 4 point something, because they've got all this custom code that was written by someone who left. In order to upgrade the kernel, they'd have to update that code, and no one wants to do that. If you've ever programmed on an embedded system like this, it's a huge pain in the butt, right?
Yeah.
Like, what do they say? Firmware is just software that's inconvenient to program.
There you go. There you go.
Yeah, no, and the idea, and even if you had, and then like let's say like you had an SBOM, right? And you're like, oh, Linux kernel version, whatever, and then you run that through, against all the CVEs against the Linux
Right.
kernel, and you get
Like
this huge,
yeah.
you get this huge list, right? Well, yeah, I mean, go tell the embedded team that you need them to upgrade to the latest kernel. They're gonna laugh at you, right? Because everything is like taped together with all those custom patches that no one understands. No one understands those custom patches, and so you just have this mess. And the last thing they're gonna do is gonna want to poke and change the kernel, right?
But
Once
that's
it's
also
running
what-
and not kernel panicking, they're gonna be like hands off, right?
But Matt, you also just explained, I think, why vendors such as D-Link has been in the news lately for not going back and patching earlier versions of their hardware and firmware, or the firmware running on older versions of hardware, for exactly the reasons you just described, right? That's why they don't want to do it.
It
Yeah.
occurs to me there's a storage story here. In the server world, server Linux, like the last time I compiled in a kernel-based driver where I had to go in and monkey with the kernel to embed the driver was
A long time
15,
ago.
20 years ago. Because now there's these entire methodologies that just let you sprawl a bunch of crap on the machine. And, with storage not being a limiting factor, OSs have become more gregarious, more generous, and more easy to use in terms of bolt-ons and other stuff. Like the average server Linux probably is 90% crap you're not even using, but it's all there anyway. Who cares? We don't bother looking. We have all the disk storage in the world. We don't care. And embedded, you're back to that. No. We can't waste space, right? And I think part of the reason we revert to these primitive approaches in the embedded world is it's actually a storage constraint over anything else.
Yeah, no, I've definitely run into that where you have storage issues. I think, yeah, because in the server world you have, I mean, Linux for a long time. I don't know what kernel version they introduced the kernel module, but it was a long time ago, right? But all this custom kernel stuff that I'm describing, a lot of the times, like they're not built as modules when they could be, right? That would be the right way to do it, because then you could update it with that, like independently of the rest of the kernel. I mean, you still need to have the kernel headers and everything, but a lot of times it is applied as like they're just going into the kernel code and just adding it like in the kernel, and then it's just all together there. No version history, no nothing, right? It's all just, they're like, oh, here is the tarball of the kernel that has all the customizations that we need, but nobody knows like how what the journey was from when they downloaded that from the Linux, like from kernel.org or whatever, and all the changes that had been applied from there.
So Matt, it's interesting because I think you and I both use a tool called Emba. It's a great team that puts that together.
Yeah.
And oftentimes when you run firmware through Emba, it does a great job of automatically analyzing what's in the Linux ecosystem. But given that there's customizations, and given that this is all under the covers, there could be vulnerabilities there that are not exploitable from, like you said, the network. The goal is to get a network-based exploit, usually through the web interface, and they're just not accessible. Also, the web servers are typically running as root, so all those privilege escalation vulnerabilities don't really mean anything because you're already root. So a lot of this is kind of a
that
moot
is
point.
my long running like meme with everybody. Like, I just don't do privilege escalation in the IoT world because it's just like, well, if you get code execution, you're root. Like, I mean, in Android it's different because they're actually doing, running a multi-user system with SE Linux enforcing and stuff like that. But no, most of these cheap IoT devices that are Linux based, that are non Android Linux based devices, everything's running as root. And if you talk to the developers, they're like, it's too hard to do privilege separation and stuff like that. So
yeah, there's no incentive for them, right? In the Android space, there's incentive to prevent people from rooting and gaining access and customizing their phones to bypass any restrictions by the carriers and stuff like that. So there's a financial incentive to put it there. In the IoT space, there isn't.
Yeah, and oftentimes the low price point of the market, you're right, is just such a constraining factor that they really don't have time to worry about the security of the device. And oftentimes you have a model where they release a product and then it's like they close up the development shop, right? That's that,
Right.
and that's what I was talking about with those build systems, right? Somebody will come along and they will build an SDK for an embedded chip and provide a build system to have like a Linux, a full Linux like file system and everything like that built around it. And then they're off to the next project or the next company, or they're a contractor, right? That just moves on. And yeah, there's not much support, ongoing support for those things.
I wonder in this whole copy paste ecosystem how much we're actually seeing whole copies transitioning devices. In other words, a commercial dishwasher running the exact same embedded code as a scale, as a wireless device, as a, like how much. Oh, we got this to work before and talk to those two kind of chips. Grab it, even though 90% of the code in it is for something else completely different, right?
Yeah, no, I've definitely seen that before. They want to. They never want to reinvent the wheel, right? Device bring up is a very expensive and painstaking process, and so that's why you also have these devices like D-Link, like running on an ancient kernel, right? Like in my lifetime have seen devices running on Linux 2.4, which I believe is when I've seen devices that are pre the implementation of memory of ASLR, memory space randomization. So you can still do like all your classic like smashing the stack and like jumping back to the stack and stuff like that, right?
Smashing the stack, right?
Yeah. like there are some IoT devices that you can still do that, and the reason again is because the cost of device bring up is so much. Again, if they have a kernel working with a chipset that doesn't kernel panic on them, they're going to be really, really incentivized to be like, no, we're going to stick with that. We know it works for this chip. We're going to build the device around that chip, and then we'll just put little user space, customizations. We'll put a new app. We'll develop the new app, but it'll still be, the core system will be the same.
Yeah. So summarizing, we're talking about reproducibility, ease of bring up, storage. Nowhere in there is security a driver for their business model. It's just not there. It's not one of the drivers.
Yeah, and I think like you are seeing this dynamic. So the other part of the business model is there's this choice between like doing like an OEM ODM model, or designing all of that software in-house and then having the hardware produced overseas, right? But you taking on that entire embedded software development in-house, which is expensive because then you're talking about paying US based engineers to do that work instead of contractors overseas. And I think there's tons of like you would have people that care about security in that space, but again, it comes down to market factors. And it's like if you're going to be selling if the price point for your IoT device is like $30 on Amazon, right? And if putting the good security work into that is going to drive that price up to $40, are you going to make that decision? I don't know.
Well, it's interesting because I think Netgear is doing a much better job than they have in the past. They've got a bug bounty program. Matt, you've participated in their bug bounty program.
Yep.
I've read their program. I think it's a very good program through BugCrowd. And but having said all that, their price point, if you look at how much they're charging for their latest routers, it's a lot more expensive than you would spend, for something similar from a different vendor.
For the D-Link, yeah.
It's true. Yeah. I did go with the TP-Link mesh system instead of a Netgear one, but or the like really expensive like Arrow ones or something like that. But
and there was a congressional document that was produced about TP-Link and how it poses a threat to our nation. And they stated like they're one of the major device providers. They're based in China, so they're a Chinese nation-state backed company, and they've got 100 million devices deployed across the globe.
Wow. Yeah, I mean, yeah, that's interesting. I hadn't heard about that. I know I've definitely looked into the Hike Vision stuff a lot because
Yes, it's another one.
that's definitely like something in my wheelhouse in my world. Looking at the security, those kind of devices. But yeah, I mean, D-Link is there. I'm sure there's millions of their devices in the United States in people's homes. So yeah.
I just thought of something. I asked about the example of, cloning the commercial dishwasher to the scale, two completely different types of devices, but hey, the code is talking on the same chips, grab it and go. I actually remembered a real world example of this. I used to work at a video conferencing company, and we had the fancy multi-$1,000 set top video conferencing units that got roped into and turned into a botnet army, not because of themselves, but because they happen to have a key chip that was accessible from the outside that was the exact same key chip in a very common Soho wireless router at the time.
Yep.
And so the botnet consisted of a
Yeah.
wireless router / video conferencing army. And it was the exact same chip that was accessible the exact same way. The exploiters didn't even realize that it wasn't even they thought it was another Linksys or whatever device they were hacking at the time. Thought it was another one, right?
That's fascinating. Was that by chance? Yeah,
was good.
I would be really curious about the network service because that definitely reminds me of in the Linux space and definitely in the router space of UP&P
I was gonna say.
implementations.
Yes.
Yeah.
The binaries, those are that gets re-implemented or not re-implemented. It gets
Mhm.
reused across a ton of
Mhm.
devices. You'll find the same exact code base, and they had tons of just trivial command injection, buffer overflow stuff that you could exploit.
Yeah.
In
This
those
was
back
a
in the
good
day.
15 years
Yeah.
ago, but it was surreal to have, my customers coming to me saying, you appear to be part of a botnet, and reverse engineering that, learning that journey and figuring out how we got roped in, why we were roped in. Like that was that was an adventure. And that was all embedded systems, 100% embedded code.
Yep.
Matt, is a lot of the entry points into these devices, and we've seen this in the commercial, space, enterprise space as well, is the entry point the web application because it's accessible. Certainly from in the IoT thing is accessible from the land side, right? But people inadvertently or maybe on purpose expose them to the internet. But the web
Yeah.
interface seems to be the common denominator. There's lots of different web interfaces, but is that your primary conduit?
Yeah, I would say IoT is definitely changing. That is still a large vector. Nowadays, you'll also see IoT devices that have zero network services that are open on the device themselves,
Right.
but they act as a client, call out to a server in the cloud, right?
Mhm.
So you don't have the same local attack surface, but sometimes it's way worse because sometimes now if I find a web app vulnerability in the cloud server, now I can pwn all the
Everyone.
devices
Yeah.
in
we've seen
the
examples.
system.
We've
Yeah.
seen examples of that. Yeah.
Instant botnet.
Yeah, exactly. So I think the landscape is changing. I mean, you definitely still have devices that have open web interfaces. I mean, home Wi-Fi routers. Most of them are still going to have those. But nowadays, I mean, these new routers, they're like, no, you got to download an app for me to configure my router. I can't just go to the
Right.
gateway's IP address in my web browser and configure it that way. No, they want you to have their app. Probably, I mean, they also want to upsell you through there, right? So I don't even know if they're doing that for security reasons. It's more like they want to have an app on your phone so that they can upsell all these services to you.
I'm a Ubiquity user here, and it's the cloud app, but it also
Yep.
forces you to install Java on your PC. Every time I see the Java,
yeah.
I just wince a little before I click my administrative interface.
Right. Oh
Matt,
yeah.
It's really funny, Matt. I was thinking about doing this project, and I think I had some really hack together thing to intercept traffic from IoT devices because I don't, like many of us, I don't trust an IoT device, and I'm going to put it on my network. Well, I'm going to put it on a section of my network that only has access to the internet, and I'm going to monitor it. And I said, I really need to create a script that turns a Linux box into a man-in-the-middle proxy. And so I clicked my heels twice, and I went on the internet, and lo and behold, it existed, and you created it. which is awesome. Tell us about this. I think it's important for folks listening that may want to get into evaluating the security of these devices, whether
Yeah.
you're at home, whether you're in the enterprise. Like, this is a useful tool to monitor the traffic before you put it in production.
Yeah, so yeah, it all comes full circle because the end goal is if you want to get a Wireshark PCAP of
Right.
your what your IoT device is doing. I've got a tool up on GitHub, called Man in the Middle Router, which all it's doing is taping together a bunch of open source Linux tools to host an access point on my computer. You can definitely use like an external wireless access point in bridged mode, but I like to have control of like the SSID and the password all myself in software, because there's some interesting attacks I can do with that setup. But yeah, basically it's going to use host APD, open source, Linux Wi-Fi router software to spin up a access point, and then it's going to connect that to a bridge interface, and then through some IP tables magic, it's going to route that out to the internet. So then you can open Wireshark on that bridge interface that the wireless is connected to, and now I can start seeing all those packets. And then a lot of the attacks I like to do, because my view of devices has always, kind of going back to the story about how I got into this, it's always from the network. How applications work and how they communicate that data on the OS, that's kind of like my second thought. But my first thought is like, what is going over the wire? And so from that point, you can see in Wireshark all of the packets going from an IoT device out to the internet or whatever, or maybe locally on the network. But then I've also got these other IP tables rules that can say, okay, maybe there's some traffic going to port 443. If we want to validate that the IoT device is actually checking the certificate to see if it is properly signed by a CA that it trusts, we can redirect traffic with some IP tables rules to a program, any kind of SSL transparent intercepting proxy, like Man in the Middle proxy. Burp Suite also has a transparent mode. You can put it in. But I usually use Man in the Middle proxy because it supports even if there's like non-HTTP based traffic inside of that TLS connection, you can do it all with Man in the Middle proxy. And so with those IP table rules, we can redirect the traffic to Man in the Middle proxy, and it has its own CA cert, right? And it will forge certificates and sign them with its own little self-signed certificate. And if the device happily accepts that, well, then you've found a big problem, right? So yeah, I've definitely done some videos recently where I had this Chinese camera, and literally every request out to the internet that used TLS, it didn't validate a single server certificate. All of them able to be Man in the Middle without installing my CA certificate on the IoT device.
Now, just when the audience wants to think this doesn't happen in the enterprise, you can go back in our research. I think it was called, we named the research BIOS Disconnect, but Eclipsium researchers figured out that certain Dell BIOSes suffered from the same problem. They didn't validate the certificate when they got updates.
Oh, man.
Which brings me to the next thing. Have you seen, and I can't remember the name of the project, and I covered it on another podcast, but there are some researchers that, well, their research is interesting. The first part of their research, they went on a shopping spree, if you will, of firmware, and they collected almost 20 terabytes of firmware. And they made available the scripts that you can go download that 20 terabytes of firmware. And then they started analyzing the firmware. It was called Checkup. I think Checkup was the name of the project.
I believe I
You
remember
this
research paper.
Yeah.
Yep.
And so then they started analyzing the firmware, and not the way Emba would analyze firmware, but they analyze it for how the firmware gets updates. And so they kind of created this very interesting research about reverse engineering, starting with just the base firmware image, reverse engineering how it would do an update, and then analyzed if that was secure or not. And they disclosed in their initial push, they disclosed 14 CVEs, brand new CVEs. from that.
Mm-hmm.
Yeah,
Which is
no,
great.
I'm not surprised at all. Yeah.
Yeah,
'Cause
when
firmware
I
updating
first
is-
signed on at Eclipsium, my
Yeah,
gaming
it's-
rig that I hand built, like that was my baby, right? BIOS on there wasn't legit.
Yeah.
Eclipsium found it. I was like, oh, I thought I went to the real website to download that. Yeah, it just let
Right.
me squirt whatever in there. Who knows what it was doing? Probably keystroke loggers and everything else for a while there. But
and that's a huge problem that goes across enterprise and consumer IoT is
Yeah.
the validation of the updates
Mhm.
isn't always sound.
Oh, 100%. Yeah, there's all sorts of fun attack paths, and reverse engineering that is always something that can take some time, right? Because there's no standardized way to do a firmware update on an IoT device, right?
Right. That's
Like
the
I
crux of the
mentioned,
problem.
so many of these devices will have a mobile app, and so you don't know, does the mobile app receive the update and then push it to the device?
Mhm.
Does
Yeah.
the device, directly accept it? I mean, well, and for BLE only devices, I mean, it has to be through the
has to.
mobile. It has to go through the mobile app, right?
And
If it's updated at all.
Yeah, we talk about
Yeah.
those constraints of things like storage, right? The reason, storage in theory doesn't sound like a big deal. I got a, whatever gigabyte card shoved in my Roadcaster here, right? Just little tiny gigabyte and done. But when you're building boards, pennies matter.
Yeah.
And so it's like, oh, I can store 32 or 16. 16 is 5 cents cheaper per chip. Let's do the 16s. And so storage becomes a limiting factor. Well, the same thing happens with the labor, right? The idea of digital signatures, a digital signature ecosystem. 90% of manufacturers could care less about that. The only ones who do
Yeah.
are the ones that stand to lose, like your Cisco's, your Polycoms, your Mitels, like the folks that produce units that if somebody, bootlegged the unit could still leverage the ecosystem and they're losing sales because
Right.
you bought my
They do it
infrastructure, but
pretty-
your
right.
endpoints are some Chinese crap over here. Those are the folks that care about digitally signing stuff. Nobody else does.
Mm.
It's just cost overhead.
Yeah.
It's another couple of pennies per unit that why bother, right?
Well, and storage is interesting, Alan, to your point, because when I think about some of the things I've got here in the studio, they're like literally light bulbs or small little plugs. Like it
Mhm.
goes into the wall and then you plug something into it and it's smart and I can turn power on and off.
Yeah.
Now, so for me, it's an economic incentive, right? Because power is super expensive. Like
Mhm.
rates, I live in Rhode Island and rates just went through the roof. So I wanted to go, when I leave here, I want to turn everything off. And I do it through these little IoT devices. But again, these devices are the light bulbs themselves or these little tiny things. They're constrained by storage big
Mhm.
time. They do have firmware updates. At least they tell me. It says it's updating firmware. I have no way to really validate that as a user, though. Right? It just goes, hey, you
I
installed
can
this new
write an app
device. I
that
need
says
to update
firmware updated.
Yeah, you check. I'm like, okay, sure,
Yeah.
great. Like, brings back to trust, right?
Yep.
Yeah, no. So the storage thing, yeah, that gets me thinking, especially in the embedded Linux space. The partition, they will plan ahead for the update process, usually to have a safe firmware update process, right? Because you don't want, if the firmware update goes bad, for the device to get bricked. They will partition two like identically sized partitions for the root file system, right? So if you're going to update the root file system, you have a primary and a backup, or like A and B, and then the bootloader will have the ability to switch between which one it's going to be the primary, right? And so that just gets into your update mechanism. If you build in a reliable update mechanism, then yeah, you're like cutting your storage virtually in half, right? Yeah.
So some of my favorite software tools, man. We're talking about tools just for a moment because I'm a huge nerd. I love to nerd out about tools, right? The Binwalk versus Unblob is a conversation that we've been having, and what I realized fairly recently was that when Refirm Labs was acquired by Microsoft, the public Binwalk repository wasn't being maintained, and someone, I don't know who this person is, I'm sure they're a nice person, I want to believe they're a nice person and very trustworthy, picked up the maintenance, forked the repository, and a large number of your Linux distributions, when you do apt and install Binwalk, pull from this person's repository. So we've got a lot of supply chain stuff going on here, right? But this is the tool that we rely on. Unblob came out later. I'm not sure what the timeline was, but Unblob, I think, does a really great job of understanding file systems and in unpacking it. So I've kind of switched from Binwalk to Unblob and wanted to get your thoughts.
I will have to check that out because I used it a long time. I tried to unblob a long time ago, and and I just haven't messed with it since. I similarly have, gosh, like every 6 months, I get this like urge to be like, I'm just gonna rewrite Binwalk in like C or so like because I yesterday I ran it on like a 16 gigabyte firmware, and it was just so slow, right? Just doing like the signature detection. I don't even think I was like unpacking stuff, right? So yeah, the speed of it is a problem, and sometimes I get bad results. I honestly sometimes end up using Binwalk as like a first step, and then I'll just end up using like DD to like to just like manually like pull out what I want, and then using the correct extraction tool from there. But no, I think there's a lot of work that can be done in that space for identifying file systems, like, and doing it fast and being accurate and avoiding some of the false positives. That's always hard. To get that balance right between your
because we're dealing with magic bytes,
positives.
And bytes can be bytes, they can be whatever. And
exactly, they can be right in the middle of your file system, right? But
correct.
Yeah.
Correct.
Well, but just having some configurability around, okay, just look like being able to tell the tool, hey, just look for file systems or something like that.
Right.
Because most of the time, that's what I care about. I don't care about like extracting out like the Linux kernel. Like, what am I going to do with this binary like image of the Linux kernel?
Right.
I don't care.
Right.
But things like that would be helpful. I get that urge to like, I'm just gonna like not hack on anything. I'm just gonna do tool development for like 6 months, but I get distracted by other stuff.
I hear you.
Yeah.
What about for Serial Console or JTAG?
Yeah, so JTAG, I don't do a whole lot of JTAG. Like I said, I'm wanting to get more into microcontrollers, and that is where that becomes more fruitful to do firmware extraction over JTAG.
Mm-hmm.
For UART, I've got the standard USB cord that just converts. It just has the pinouts for 3.3 volt UART, and it converts it to a USB adapter. I also for non 3.3 volt UARTs for your odd voltages, I actually have the JTagulator from Joe Grand, and one of the like really lesser known features in there, because it's kind of a side feature, is that it can be a variable voltage. Like, you can programmatically set the voltage for a UART pass through, so it can be a 1.8, a 3.3, whatever voltage you want, a UART adapter. So if it's not 3.3 volt, which most stuff is out there, but if it's not, then I default back to that JTagulator device, which is nice.
That's awesome. Yeah, I didn't know that. Now I have to go AliExpress shopping for a JTagulator.
you do, because it's discontinued. Yeah.
Right.
So
but AliExpress is a great place to get some of these tools, although buyer beware, right?
Yeah, buyer beware, exactly.
It's a cesspool, for sure.
It's great if you're looking for random reverse engineering projects, though.
Yes, to find targets.
Yeah, exactly. Find hacking targets. Great.
Yeah, I picked up some Android phones that are on my list to look at for sure. Yeah. Alan, I knew you have to drop soon. Did you have any more questions for Matt?
Man, I'm floored by all this, and your YouTube channel. So much content, so much cool stuff.
Thanks.
What's your message for those that want to get into this?
Ooh, yeah. So I would say let your passion like drive you to the part of hardware hacking, because I mean, hacking is a really big space and you can get overwhelmed by it. But I would say even hardware hacking, once you get into it, there's like we're even talking about like I want to learn more about microcontrollers. There's microcontrollers, there's Linux, there's firmware extraction, there's all these different domains. And so just like find a project, and then so some people will ask me like, what tools should I buy? And I really dissuade people to be like collecting tools. A tool should solve a problem a roadblock that you have hit in your goal to do something to this IoT device, to reverse engineer it, to pull the firmware off, to exploit it, something like that. So I would just pick, an IoT device. What I would do when I started out this stuff, I would like go to my local Goodwill, and they'd have, cheap like $5, $7 like old routers. Take it apart, and try to do something to it. Try to find UART. Try to extract the firmware, and then that will lead you to the tools that you need to buy.
I love it.
And you can get away with inexpensive tools certainly to start.
Oh yeah, and that's the thing. Like, that's hard with my videos. I try to like stress that in the comments. I'm like, I did not start with this crazy setup, like a microscope that I can record under, and like all this stuff. Like, you don't need any of that. Yeah, you need the basics, and the basics are pretty cheap.
For sure. And then, it can get more advanced from there as well with the DediProg has a great platform, right? I typically recommend that if you're doing that as your profession, that's your job, that's probably a platform you want to look at. If you're just getting into it, I mean, there's inexpensive, you don't have to go to AliExpress. I got a lot of inexpensive, USB to serial UART adapters on Amazon for $9.99.
Oh yeah.
Start there.
Nice.
There's some
Exactly.
good stuff there.
Definitely.
Well, awesome. Well,
Thanks
Matt,
for having me on.
yeah, man. Thanks for
It was
coming
fun.
on the show. I learned some stuff, and I thought it was a great conversation. I love the conversations about supply chains. I think we did a good job of kind of weaving that into the conversation and realizing that while it may be an IoT device, it shares a lot of similarity to other things that you'd find in the enterprise as well. And these problems are, crossing industries in different sectors. So that's important as a takeaway. So
Definitely.
awesome.
Yep.
Thanks
Thank
so
you,
much, Matt, for appearing on Below the Surface. Thanks everyone for listening and watching. We'll see you next time.